Hey guys, I have here the Graphing Quadratic Functions worksheet. Today in class, on day 3, we talked about different forms of quadratic functions. If you look through this assignment, you'll notice that the first page is a specific form called vertex form. The second page is going to be on a form called factored form, sometimes called intercept form. On the last page, we have two equations that are in standard form, which we'll kind of talk about as well. And then there's some factoring practice. Okay, so if you missed class on day 3, I would recommend that you go back and view the resources that I posted under the day 3 heading in Canvas, because I found some really good videos to kind of help you out. And we spent the first, 15 minutes of class just talking about factoring and reviewing factoring. So that might be something you need to go back and review. There's a couple videos I posted on factoring and solving equations by factoring that might probably want to be familiar with before you start talking about these graphs. And then there's a couple videos I posted on different forms. Okay, so go do that first if you maybe need a little bit more from today's lesson, or if you missed today's lesson, you're going to want to check those out. Let's talk about vertex form here. Okay, vertex form looks like this. Okay, so you have a couple different pieces here. You have this A, which represents the vertical stretch factor, and if A is negative, then the graph points down. You have H, which represents the horizontal shift, and we know that the shift is actually opposite of what's in here, which we'll talk about in just a second. And the K represents the vertical shift. Okay. So let's look at some of these here. Let's take a look at number 2. Okay. So in number 2, we see that the A value is positive, and since the A value is positive, I know that this graph is going to open up. In other words, it's going to look something like that. Okay. The reason why this is called vertex form is because I can easily grab the vertex from this form. I know that the vertical shift is -9 or down 9, and then the horizontal shift, I'm going to take the opposite of that number inside. This negative here indicates that we need the opposite of whatever that number is. In this case, we'd want a -1. So that's where the vertex goes. Okay, the vertex is, we talked about this in class, it's the pointy part of the parabola. It's the very lowest point if the parabola is facing like this. If your parabola is facing the other way, it's the top. Okay. And the axis of symmetry, another thing we talked about in class, is basically the line of symmetry. Okay, it's called the axis of symmetry because we're talking about graphs, but it's really just the line of symmetry. And it's a vertical line, and it has to go through this vertex. It goes right through the middle of the vertex. Okay, so let's start with the graph that we have so far, and then we'll kind of come back and figure out the axis of symmetry. Okay, so let's start with the vertex. So -1, -9. That's going to be down here. Okay, we also know that this is going to open up, so it's going to be kind of something like that. We don't know exactly how that's going to look yet, but we do know that the axis of symmetry is going to go right through that vertex. Okay, that's going to kind of cut the graph into two mirror image pieces, or two symmetrical pieces. That line, that vertical line, we represent with this equation, x equals -1. Okay, now we just got to figure out how wide the graph is. So I'm going to switch to pencil really quick because I want to kind of graph the original function. Okay, when we graph the original quadratic, the parent function, it has these key points that we've talked about many times: 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4. Okay, this guy right here is a stretch factor, and so it's going to stretch out all those points. So instead of being, this point here being at 1, 1, it's going to be at 1, 3. Right? It's going to stretch by a factor of 3. And this point, instead of being at 2, 4, it's going to be at 2, 12. Right? And this guy here will also be -1, 3, and then -2, 12. So stretching my graph would look like this, but of course my graph isn't here, it's way down here. Okay, so basically what I need is I need these 2 points, but in reference to this vertex. So if you notice, this point here, it would be 1 to the right and 3 up. Normally, in my parent function, my graph would look like this, right? But this point now, instead of being up 1 and right 1, it's going to be up 1 and right 1, 2, 3. And since the graph is symmetrical, we're going to have another point here. So let me switch back to pen. Okay, so we know we got those 2 points. Also, if I go over 2 units, instead of going up to 4, I'm going to go, or going up 4, I'm going to go up 12 because it's 3 times as big. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I got that point here. And then same thing over here. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm using the original points of the parent function to kind of like get reference points for, this parabola. But since it's going to be stretched, those points are going to be 3 times farther away than they normally would be. Okay, so that's what my graph looks like there. Okay, so that's transformational form. Now that's very, very similar to the transformations we did on day 1. We just didn't know that it was called vertex form. We hadn't really talked about the vertex and what that was. We hadn't really talked about the axis of symmetry. So a very similar idea. We just have kind of specific names for things now, and we know now why this is called the vertex form. Okay. If you need a little bit more help with vertex form, again, I posted a video on vertex form that's good that you can kind of check out and learn about the different pieces of vertex form and how those graphs work. Okay, next we have factored form. Okay, so let's take a look at a few of these. Before we get too far, I just want to talk just really briefly about solving quadratic equations, which I did post a video of, but in order for this to make sense, we kind of need to know some stuff. All right, so imagine I had a quadratic equation that looked like this. Okay, and I wanted to solve that for x. Well, there's this thing called the zero product property, which basically says when 2 things get multiplied and the product is 0, then you know either A is equal to 0 or B is equal to 0. One of those 2 pieces has to be 0 to get a product of 0. Okay, so notice here I have a product of 2 binomials, and I'm multiplying those and I get a 0. So that means either the first factor, the first binomial, has to equal 0, or the second factor has to equal 0. Okay, so if I solve this for x, I get x equals 3 over here, and over here I add 7 to both sides and I get x equals 7. Okay, these are my solutions. Now let's think about this from a graph perspective. Okay, if I have f of x equals x minus 3 times x minus 7, right? Now we have a function, right? What does it mean for that function to have an output of 0? This is basically like your y value, right? So you're basically, you're basically saying that y is equal to 0. Well, on a graph, when y is equal to 0, that's the x-axis, right? That's like 0 high. So when you solve this equation and you get 3 and 7, what those are points on your x-axis, right? So when x is 3, y is 0, right? If I plug a 3 in here, I have 3 minus 3 times 3 minus 7, 0 times negative 4 is 0, right? The output is 0. In other words, I already know what the y value is. The y value is 0. I'm solving for the x values, and these are the 2 values. Sorry, that's a 0. So those are actually what we call x-intercepts. 1, 2, 3, 4, 5, 6, 7. Okay, my graph has to go through those 2 points. So it's going to look something like this. Okay, now the question becomes, well, where's the vertex, right? How wide is this graph? And there's 2 really good videos that I posted on factored form that explain all this in more detail if you need more examples. But just for this guy, I'm going to show you how to find that vertex. Okay, so that's kind of the basics, right? We have to understand solving and this kind of setting equal to 0 thing to understand this next form. Okay, so factored form looks like this: f of x equals a x minus p x minus q. Now in the video, I think they use different letters. They use r and s, I believe, but it doesn't really matter what variables you pick. The idea is p and q are your x-intercepts. Okay, now the negative again indicates opposite here. So when you look at a function like this, you're like, oh, my x-intercepts are 3 and 7, the opposite here and the opposite here. The reason why is because we set each equal to 0 to solve, right? So we want a positive 3 and a positive 7. Okay, so going back to this guy, if you don't see the a here, right? There's like no number out there. So that means that a is just 1, okay? Positive number, which means it's going to open up, or it's going to look like this. Okay, again, we know the x-intercepts are 3 and 7. As coordinates, that would be 3, 0, and 7, 0. Just kind of showed you that. Okay, so let's plot those on the graph. Okay, now here's where it gets kind of interesting. The axis of symmetry has to go straight through these guys. Okay, just like that. Because this graph is symmetrical. So the axis of symmetry is halfway between 3 and 7, and it looks like in this case that's going to be 5. Since it's a vertical line, I'm going to write x equals 5, because that's how you write the equation for a vertical line. Okay, now this is, again, another kind of tricky part here, the coordinates of the vertex. What I need to do is I need to plug this into the function. I know the vertex is going to be on the axis of symmetry. It's got to be right in the middle between these 2 points, but I just don't know how high to put it. So I already have the x value of the vertex, right? In other words, 5 comma something, right? It's going to be somewhere on this line. I just have to figure out what the y value is, or what the output is. So what I do is I take this value and I plug it in the function to see what the output is. So I want f of 5, which in this case will be 5 minus 3 times 5 minus 7, or 2 times negative 2, which is going to give me a negative 4. So my y value is negative 4. So I have the point 5, negative 4, right? And it's right on the line of the axis of symmetry, just like we expected. So this isn't like a perfect graph, but we know where the vertex is now, and that's kind of important. And we also know where these intercepts are. So we can kind of gauge, about how wide this thing is going to be, at least for a while, by, those x-intercepts. Okay. Now, there's a couple down here that are a little bit tricky, okay, 7 and 8, so we'll talk about both of those. Because this one, it doesn't look exactly like this. Okay, so I'm going to rewrite this one for you and see if it makes a little bit more sense. So what if I had 3 times x minus 0 times x plus 4? Okay, so that x I'm writing is x minus 0, right? Now it's a little bit easier to understand what's happening here. The 3 is the a value, the stretch factor, and it's positive, so this guy's going to open up again. Okay, now the x-intercepts are, again, the opposite of what's inside here. The reason being is when you have an equation, let's go back to an equation, 0 equals 3 times x minus 0 times x plus 4. What you need to do to find x is set each factor equal to 0. Okay, so for this one, it's just 0. X is just equal to 0. For this one, you have to solve x equals negative 4. Now there's that 3 out there, but that doesn't have an x in it, so that's never going to give us a 0, right? When does 3 equal 0? Never, so that's not going to work. Right, so your 2 zeros for this one is just 0 and negative 4. Right, so 0 for this guy, negative 4 for this guy. As coordinates, those are 0, 0, and then negative 4, 0. Okay. So let's plot those here. 0 and negative 4, 0. Okay, axis of symmetry, again, has to be halfway. which means it's going to go right here through -2, so x equals -2. Coordinates of the vertex. Okay, so we know the vertex is going to land on here, so we know the x coordinate already. It's got to land on that axis of symmetry. It's got to be kind of in the middle. We just need to find out what the y value is, or what the output is for that value. So I'm just going to plug that in. Whoops, -2 plus 4. All right, so 3 times -2 times +2, right? -2 plus 4 will be +2. And that's going to be, this is going to be a -6 times 2, which gives me a -12. Okay, so I'm here at -2, -12, way down here. So this is going to be a pretty skinny graph. We have a couple points here that are going to kind of give us an idea of how wide it is. Okay, so that's your sketch. A little bit tricky because it didn't look like normal, but that's okay. That x is just like x minus 0. You can kind of write it how you want. Okay, here's another tricky one, number 8. Okay, and the reason why it's tricky is because of this guy and this guy. Notice that in your form, like, that's not really there. So you could like try to factor it out, but what's going to happen if you try to do that is these are going to become fractions, and that's okay, but let me show you another way of thinking about it. Okay, so you don't want to say the x-intercepts are not they're not 1 and -5 in this case. I know that that's kind of what I've been telling you, right? The x-intercept's -1 and +3, +3 and +7, 0 and -4, right? We're taking the opposite. But in this case, it's a little bit different because of that 2 there. So let's go back to our little scratch paper here and talk about solving again. So we got negative, we got 2x minus 1, and then 2x minus 5. And I'm setting it equal to 0, right? Because that's going to be like the x-axis when y is 0. And we're going to solve this guy. Okay, one thing to keep in mind is this is a -1, if you want to think of it like that. So this is my a value. Doesn't really matter for x-intercepts. But if I'm solving this, then I know either 2x minus 1 equals 0, or 2x minus 5 equals 0, or both, going back to that zero product property we were talking about. So I actually got 3 things that are getting multiplied equaling 0. One of them's got to equal 0. So I could also write the equation -1 equals 0. But I already know that one's not equal to 0, right? That can't work. So that's not the 0. That means this piece is the 0 or this piece is the 0. Okay, so we got to solve it. When I solve this guy, +1, I get 2x equals 1. Over here, +5, I get 2x equals 5. Okay, and then I divide both sides by 2, and I get x equals 1/2 and x equals 5/2, or like 2.5, basically. Okay, so that's a little funky, but we can still kind of figure that out based on our zero product property. Okay, so not quite as easy as just grabbing them because of these guys. All right, so let's go back to our assignment here. Okay, let that color adjust as I'm moving from the orange paper. So my a value, again, is that -1. Okay, so this is going to open down. My intercepts are the 2 that I solved for. They're 1/2 and 5/2, or as coordinates, 1/2, 0, 5/2, 0. And remember, 5/2 is like 2.5. Okay, let's graph those. So here's 1/2, and then 5/2 is 2.5. Okay, so what's right in the middle between those is, should be, I think it, let's see, 2 and, oh sorry, that's why I put it too far. So 2.5 is right here. Okay, so if I put those together and average, then my axis of symmetry will be here at 1.5. Okay. Hold on a second. Let me back up the train. I made a mistake. Because one of these has a plus in it. That's why this isn't working out the way I thought it would. Okay, so that changes things a little bit, but let's go back and fix this. Okay, 2x plus 5 equals 0. So I'm going to minus 5, actually. Minus 5, minus 5. So that'll be a negative 5 halves. Okay, I was wondering why I was in the middle. I didn't think I planned on that. So we have the 0, 1 half, and then this is negative 5 halves. So not this guy. Sorry, it's getting a little messy. Shouldn't have done it in pen. Let me switch to a fresh copy. All right, sorry, one more time. Direction of opening, down. Right, it's going to go like this. X-intercepts, 1 half 0, negative 5 halves 0. Sorry about that. Okay, so let's graph them. We got the half here, and then we got the negative 2.5 here. Okay, that's much better. So the halfway point here is negative 1. X equals negative 1. All right, coordinates of the vertex. We don't know where it's going to land. We don't know where the vertex is going to land. So we have to plug it in. We know at least part of it, right? We know half because it's got to land on this line. So we know the x coordinate. Now we just plug it in. F of negative 1 equals negative 2 times negative 1 minus 1 times 2 times negative 1 plus 5. So this is going to be negative 2 minus 1 would be negative 3. And then this is going to be negative 2 plus 5, which is positive 3. So it looks like we're going to be up here at positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we know this thing is going to open down, so there we go. All right, got it. Again, sorry about that mistake, but something like that. Just copied the problem wrong. All right, let's look at the next piece here. Okay, now these guys are in what we call standard form. Okay, so the first thing we need to think about here is, what is the factored form, or can we factor it? Let's look at number 10 because that one's a little harder. So I would start by looking for the greatest common factor. In this case, that would be negative 2. Factor that out, and I get x squared plus 2x plus 3. Okay, so then I factor that further, and I'm going to I need factors of, oh, sorry, minus 3. It's getting late, guys, sorry. All right, so we have a minus 3 there when we factor out the negative 2, right? Just to double check, negative 2x squared minus 4x, and then negative times negative is going to give me my positive 6. All right, so we need factors of negative 3 that combine to 2. That looks like it's going to be a plus 2 and a plus 3 and a minus 1. Okay, those will multiply to negative 3 and combine to 2. All right, cool. So now our zeros here. We got our negative 3 and 1. When I say zeros, I mean x-intercepts. It's another way of saying x-intercepts. So negative 3, 0. Okay, and then we got 1, 0. Right, because of this guy, we know it's going to open down. Okay, we'll come back to the y-intercept in just a second. The axis of symmetry is going to be in between those 2 points. So let's kind of see what's in between. 1, 2, 3. There's negative 3. There's 1. Looks like, again, negative 1 is right there in the middle between those two. So we got axis of symmetry at x equals negative 1, which means my vertex has to land somewhere on there. So my x coordinate has to be negative 1. I just got to figure out what the rest of it is. So I'm going to plug negative 1 into this guy. So negative 2 times negative 1 squared minus 4 times negative 1 plus 6. If we do the order of operations correctly, this comes out as a positive 1, and then I multiply that by negative 2. This comes out as a positive 4, and this comes out as a plus 6. So altogether, it looks like that's going to be a positive 8. Okay, now the y-intercept. We talked a minute ago about how to find an x-intercept. We make y equal to 0, or f of x equal to 0, right? When y is 0, we're on the x-axis. Well, what about the y-intercept? Okay, well, when we're on the y-axis, x is 0. So all I need to do to find the y-intercept is just make x 0. I need to find f of 0. Well, if I plug 0 in, this is negative 2 times 0 squared, so this is 0. Negative 4 times 0, that's 0. All I have left is this piece. So when x is 0, and I plug in 0 to this function, I just get out a 6. Okay? We're going to talk a little more detail about standard form in our next lesson next week, but the idea is this piece right here is the y-intercept. Okay, so 0, 6. All right, so we got our x-intercepts, we got our axis of symmetry. Let's put our vertex in there. Negative 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. We also got this other point now. We got our y-intercept, which is kind of nice. So that point is right there. That's 0, 6. And since we have some symmetry here, we know that there's got to be another point on this side because it's symmetrical. And now we got a few good points to work with. So we'll go kind of like that. All right. The rest of this assignment is factoring practice. So I posted some videos to help you factor. These are all just basic trinomials. These 4 here are pretty basic, but you have to pull out the greatest common factor first. So this one has a greatest common factor of 5, so start by factoring out 5. Same thing with this one. This one has a common factor of 2, so factor that guy out. This one has a common factor of 6, so factor that one out. And then once you do that, it'll look more like these, and you can kind of go from there. Okay? I hope that helps. And I posted with this assignment, I posted the answer key to the odds if you want to check yourself. But again, just use that as a checking tool. You want to know how to do this. If you just go through and put in the answers, it's not really going to help you a whole lot, and you're going to not do very well on the next test. So keep that in mind. Thanks for watching. I'll see you guys in class soon.